Well, I decided to do Charles' Law because it is a part of chemistry, the gas laws, and I happened to find a simulation that reminded me of the piston, which I was like, wow, that kind of ties into the Kate department and physics, so I think I finally found something to connect. Okay, so, okay, of course, I'm Thelma Hernandez, and I teach grades 10 to 12, AP Chemistry and Chemistry 1. The presenter I went ahead and picked with the help of my co-partner over here is Anna, the one that did the pressurized suits, because we are talking about pressure. So pressure in the capsule, pressure in the suit. So later on, hopefully I can tie it into her work. I have some of her presentation slides that I can tie in later. Haven't put in there yet. So I used her as the model person. And if you notice, it's a big lesson overview because I'm talking about solids, liquids, and gases, how they relate with each other. I'm actually giving what is pressure, what is temperature, how does it relate, that type of thing. So that would be like the general overview there. And then the kids that would be coming into this would be 10th to 12th graders. We don't usually have freshmen, although I've had one or two in the past. And they at least have to come in with the knowledge of Algebra 1. We were debating, do they have to have Algebra 1? Well, like James was saying earlier, our kids are getting it way. My daughter was in 4th grade doing dimensional analysis, blew my mind, but he's right. So they technically should have it. She's pre-AP GT kid, so I don't know if everybody gets that, but I know for a fact she has that under her belt back then. Now whether she'll remember when she gets to us, that's another story. There's a relationship, the learning objectives, that there is a relationship between volume and temperature. What is Charles' Law? What is the relationship between volume and temperature? What when pressure is held constant? Okay, because we also talk about Boyle's Law, which is different, and so the main objective in this case is for Charles' Law. All right. What happened? Luckily, it tied into NASA events. So I'm going to try. This is what I would call my discovery lab. We call it the Explorer and C-Scope. I found this kind of nifty thing on the web that Ivory soap. I don't know if y'all know that. That there was a fluke when the guy was making the soap. He left the air compressor or air whatever on, and it added extra air to Ivory soap. And so it's one of the only soaps that actually floats in water. So the experiment would be having the kids bring a bunch of bars of soap in, putting them in water, and the majority of them will sink to the bottom. Ivory soap actually floats. And then what you do is you say, why does it float? Well, there has to be air in it. But if you actually break up the Ivory soap, you don't see air pockets in there. There are no air pockets. And so that goes against, well, there should be holes like a sponge, right? But there's not. So when you actually, so what this thing is, like I'll show you, I got this off of YouTube. Let's see if it'll work. You actually put this in a microwave. And you ask the kids predict what's going to happen, you know, that type of thing. Let's see what's going to...
To play.
Oh, thank you. Okay. Maybe not. Try again. I tell you, I was having problems with this. Okay, let me see if I can. Do you want me to try to get it off the YouTube web?
Sure.
Okay. Oh. Just go to the page?
Mm-hmm.
Maybe this one, I'm not sure. Yeah, I think this is it. It takes like a minute or so.
It's interesting how it
You can tell
started
the
at the
chemistry
top.
teacher's in the room. Everybody else is like, huh?
I'm just amazed that it started at the top and took off and not like,
Started
all the way
this-
around and just,
Yes.
it did, it's
Yeah.
only started at the top.
So actually, I put this in for the teacher part of it. I would actually have the kids, because I have a microwave in my room, I would actually have the kid do it in my classroom. But I just thought this would be kind of cool for the teachers to see it. So in my plan,
This would
This
be
is
a whole
perfect.
new way to clean your microwave.
yeah, I thought that would be a great way to.
Yeah.
It smells like though.
But it's perfect since if you were doing this for teachers, a presentation on your lessons, you put this in and it's
Put
perfect.
it on top of the pie to give to a student I don't like.
Now, would you have them test a different bar of soap to see what that would do? In
I probably would, like, at least try one bar, because one of the ones that didn't float.
I respect.
And I believe actually they take it out so you can see what it. Evidently, it still feels like soap from the other videos I've watched. And then they said, well, don't throw it out. You can actually take it and use it. Which I don't see how.
Make your own loofah.
Yeah,
Homemade loofah.
Brand new, Expando soap.
and here they are, soak it out.
I got a new one for you. Before you put it in there, hollow it out just a little bit, put some food coloring, and see
And
when
see
it
what happens.
bubbles out, if it bubbles out in color or it swirls or something.
That's interesting. Okay, so anyway, okay.
Goldfish in the microwave.
Oh no, that I can. Okay, so
Focus.
actually I have let me see, where do I have it? I made a worksheet for this, but I'm just having problems finding things right now. I think I have them in different locations. Oh, here's it. Soap Souffle Lab. So this would actually be, I haven't done the, this would be the material part of it for the kids, but I haven't made the lab worksheet for it, what they would see or whatever, what do they think. That I'm still working on. But for the teachers, I went ahead and put this facts for teachers, you see at the bottom. So I gave them a picture of it and why does it work, and it talks about, air, the gas pressure escaping, not the pressure, but the, like the popcorn, they're escaping out. So, so I gave an explanation here for the teachers in case they didn't understand what was going on. Okay, so we go back to, okay, where was I? Oh, okay, and then I found this really cool, and it was a free PowerPoint on the web. So, and I think you guys might like this. Let's see if it'll let me open it up. Okay, yesterday I was giving you the same problem too. So I don't know how else to get this off of there without having to see if it'll let me do it. Okay, so I'm going to do it now.
I wonder if it has to be me instead of you.
Oh, well, see, all of a sudden, see, it just does weird stuff and then all of a sudden it starts.
Oh, that's it, all right. So, what did you do?
Yeah. And so this is a whole PowerPoint on. And I know you were thinking of doing stuff with balloons, right? Something? And it talks about the person that came up with the idea, what the temperature does to it. Goes through a whole bunch of different aspects of Charles Law and why it's the way it is. And it actually goes through the calculations, why it ends up being. I like the fact all the balloons are going through it all. This kind of makes it interesting. Raising the temperature causes pressure greater volume, and so it just gives a real nice little quick synopsis of what's going on and the calculations that you have to make. And then here it actually gives you a little experiment using I think liquid nitrogen. It says you dip the balloons in the beaker, the air quickly cools out. It also talks about the pool. You know, when you go to a pool, you know, you go to Schlitterbahn, and sometimes those tires feel like they're deflated. You know, and it has to do with the temperature. And so it shows. And then actually introduces a little bit of Boyle's Law into it, so you can compare the two laws. And then practical applications, you know how we want to relate things back to real world. It talks about the hot air balloon stuff. So I thought that was and it talks about it being donated, and so I said, it's free, I'm using it. And actually I found another one. So in the teacher guide, I actually found another one that has Snoopy and Charlie Brown and doing some other things. So they actually put several references in the teacher part, so they didn't like that one, they could pick the Charlie Brown one or whatever. And then the procedure, I'm still working on that. I think I had one. Did I get one done? Or just that part of it? So the rest of this, let me just show you what I have actually in my folder here. Let's see. Okay, I've already made notes for it for my students. I actually would put this up, and they would do Cornell notes on this information here. It actually goes through a couple examples of calculations, how they would actually calculate it, so they would have reference to go and do work later. So that's what that is. It's just the notes. Okay. And then, oh, this was the how does it work thing. Let me close that out. And then I actually have problems. I did 2 problem sets for them. Usually what I like to do with the kids, I give them one set. They go through, they can mess up on that, whatever. We vote whether we put in the grade book or not. Then the next day I give them the second worksheet that goes in the grade no matter what happens. So that they don't get a vote on that one. It's usually how I work in class. So I have 2 worksheets for this. And it's calculations. I would have to make the keys still. I don't have the keys made up for that. Let's see, what else do I have? Let me see. Oh, and this, let's see if I can see it. This goes with the simulator that I found. The problem. Yeah, I have it in here. Let me. And this actually goes along with that. This is this would be like the worksheet, and they'd have to actually do this. Let's see, where did I put it? Where are you? Charles Law link. Let me see, what's that one? No. Oh well, it is. Let me see if I can copy. Okay, and here's the one that I was telling you that it looked like a piston. And actually the lab that goes along with this is that they actually will move this. I think I said start at 300. And it tells you that you have to let the piston, and it's going to draw a grid up here for you, and you actually let the piston rest. It's going to stop. And then you would then input your next temperature point, right? So I tell it subtract 20 degrees every time till you get to, I think I said 80. Something like that. So you'd actually move this thing down, and you actually will see the piston going down. If you raise it up, you see it going up. So it goes along with that little lab. And then I found that NASA actually had one itself too, so I put that link in, the NASA link in here. I didn't like it as much because it's not as interactive. It's like a simulation, like you click it and it goes. So it was good, like if you wanted to show the kids, but this one actually, they can actually move the dials and stuff and make the things move up and down. So let me see if I have the one for NASA here. I don't think I put it here yet. But anyway, there is, oh, I think I have it in, hold on, where's that one? I think I have that link. Where is it? I thought I had already put it in here. Oh no, it's in the lesson plan, sorry. It's in the lesson plan. Which is my lesson plan. Got so many things open now.
Try all the way to the right. Or no, the front, I'm sorry,
Oh.
the left. It's the only other Word
Yes.
document.
Over here, oh,
Yeah.
okay, it's down here. And I actually made a, there it is. So here's the one that's actually on NASA. If you go to actually to that website, these things you'll see it moving up and down. You'll see the graph being input and outputted. So, well, let me see if I can copy this link real quick so y'all can see that. Copy. And there it is. Let's see it. And this is the one from the NASA website. It says freeze to. So I froze the mass. And then I froze the pressure. And then it should automatically go, I think.
You can click one of the hyperlinks on the left to make it go.
Where?
See on the left where it says effective changing volume on temperature?
Oh,
Effective-
thank you.
yeah.
Yes, you're right. So that was just a good one for like an intro. But the other one they actually get to play with, and the lab goes with, they have to put the dots, they have to plot it, and then they're going to have to graph it and all this stuff. But I thought this was pretty good to put like in an intro. And that's why I saw, oh, that looks like a piston, you know, going up and down. So I thought it worked pretty well for that. And let me see, do I have anything else? Oh, that was for the ivory soap one. Materials. So I've got a lot of stuff, but it's like scattered. Okay, I think that's probably it that I've gotten so far.
Any questions? All right, then I'm gonna ask them.
Oh. Darn!
Maybe I'll ask them first. This is what I took away. I think the model in your lesson is the piston, because it's a good model of what happens with the temperature change. The simulation was the other thing you put up there, and I lost it. You had where it would draw the graph.
Right.
And what was that?
Well, they both had the graph on it. The only thing is, and that one was
Yeah.
free animation, where the other one, if the kids plug it in, they actually have to watch the piston and see where it moves. you know.
Right, yeah, but I'm in my mind trying to figure out which I would call the model and which the simulation is where they can keep changing numbers.
That's why I
Data.
put that one in. The one that they actually have the lab part to it
Okay.
is the one I would consider the using simulation. The other one would just be mainly just animation for.
So I just
I
found
think
a net logo one online also. I can send you a link.
The one?
I just send you another simulation link that
Oh,
has
okay.
also a bunch of buttons that you can use to
Oh,
increase
great.
temperatures, it's volume.
You send it to Karen? Okay, then maybe it's
If you guys have ideas, and you have to do this with each other, give Thelma any ideas. This is the one I have, and I think you could create a spreadsheet that would be like a simulation, like Catherine created one, but the relationship of temperature and pressure down here, I would think of car tires. And I mean, you guys were having 105-degree temperature. You've got to be making some kinds of adjustments from time to time.
Well, even in the
your
winter,
automobile.
because I have the sensors in my car, and when
Yeah.
the winter, my sensors will go off
Yeah,
because my pressure's changed.
so.
So to send it to real life, I was talking about the piston thing, or now that, because I was thinking the Schlitterbahn, because we go to Schlitterbahn, and they've got the tubes that you sit in,
Yeah.
you know, and a lot of them, they're all deflated and stuff, and, you know. And then, of course, with stuff with the astronaut suit and stuff. So that's as far as I've gotten, guys.
It's a lot in a very short amount of time.